Today we are going to learn about mastering LIME, interpret ML models effectively. We will explore how to utilize LIME in interpreting machine learning models, enhancing transparency and decision-making skills in AI systems. Welcome to the video on mastering LIME, short for Local Interpretable Model Agnostic Explanations. LIME is a powerful tool designed to enhance the interpretability of machine learning models. In this video, we'll explore how LIME can be applied to decode complex models, helping you make informed decisions based on AI predictions. By understanding LIME, you will gain insights into model transparency, ensuring trust and reliability in AI systems. Let's dive into how LIME can transform your approach to machine learning model interpretation. To effectively use LIME, setting up a proper environment is essential. You'll need Python installed on your system, along with libraries such as NumPy, Sklearn, and of course, LIME. Start by installing Python if it isn't already. Then, use pip to install the necessary libraries. A quick command such as pip install LIME will do the trick for LIME. It's important to ensure your environment is ready to work with datasets you wish to analyze. Consider downloading a sample dataset like the Iris dataset to test your setup. Once everything is in place, verify your installations by importing these libraries in a Python script. This preparation ensures that you can smoothly follow along with generating and interpreting LIME explanations in later sections.
Choosing the right model is crucial when planning to use LIME for explanations. LIME is model agnostic, meaning it can work with any machine learning model, but selecting an appropriate model enhances interpretability. Consider models that are complex enough to require interpretation but not so complex that explanations become too convoluted. Models like decision trees, random forests, and neural networks are excellent candidates. The goal is to strike a balance where LIME can provide clear insights into how each feature affects predictions. This choice will directly impact the clarity and usefulness of the explanations LIME generates. By selecting the right model, you ensure that the explanations are not only accurate but also actionable.
LIME is particularly effective in generating explanations for classification models. Begin by training your classification model on the dataset. Once trained, LIME helps in creating local explanations for individual predictions. It does this by perturbing the input data and observing the changes in the model's output. This perturbation process creates a new dataset that LIME uses to train an interpretable model, such as a linear regression model, which approximates the behavior of the original model locally. For instance, with a model predicting whether an email is spam or not, LIME can highlight which words or features contributed most to the prediction. This is particularly beneficial in industries like finance and healthcare, where understanding individual predictions can have significant implications. The output generated by LIME consists of weights and feature contributions that are crucial for interpretation. Each feature in the dataset is assigned a weight, indicating its contribution to the prediction. Positive weights suggest a feature pushes the prediction towards a particular class, while negative weights suggest the opposite. Understanding these weights can provide insights into how the model makes decisions, enabling users to trust and verify the model's predictions. For example, in a healthcare model predicting disease risk, certain symptoms might have higher weights, indicating their significant impact on the prediction. This granular understanding aids in real-world decision-making, allowing stakeholders to interpret and act on AI predictions with confidence. Visualization is a powerful tool for interpreting LIME's output. By converting LIME's explanations into visual formats, you can enhance understanding and communication of model insights. Tools like Matplotlib and Seaborn in Python can be used to create bar charts or heat maps that display feature contributions visually. For example, a bar chart can show how different features influence the prediction of a model classifying customer churn. By visualizing these contributions, stakeholders can quickly grasp which features are most influential, making it easier to present findings to non-technical audiences. Visualization not only aids in interpretation but also in validating the model's behavior, ensuring that it aligns with domain knowledge and expectations. While LIME is a powerful tool, there are common pitfalls to be aware of to ensure accurate interpretations. One such pitfall is misinterpreting the locality of LIME explanations. LIME provides local, not global, explanations. This means it explains predictions for individual instances, which might not generalize across the entire dataset. Another pitfall is using LIME with poor quality data, which can lead to misleading explanations. It's crucial to ensure data quality and pre-processing before using LIME. Additionally, understanding that LIME is an approximation of the model's decision boundary is vital to avoid overconfidence in its explanations. By recognizing these pitfalls, you can enhance the reliability of Lime interpretations, ensuring that they contribute effectively to decision-making processes. Lime's ability to interpret machine learning models makes it invaluable across various industries. In finance, Lime can help in explaining credit scoring models, allowing banks to understand the factors influencing credit decisions and ensuring compliance with regulatory requirements. In healthcare, Lime is used to interpret models predicting patient outcomes, providing insights into which factors are most critical for diagnosis and treatment. Retailers use Lime to understand customer behavior models, optimizing marketing strategies based on features that drive customer purchases. Across these industries, Lime enhances transparency, allowing businesses to make informed decisions based on a clear understanding of model predictions. By applying Lime, organizations can build trust in AI systems, ensuring that decisions are data-driven and aligned with ethical standards.
In conclusion, mastering Lime equips you with the skills to interpret complex machine learning models effectively. Understanding Lime and its applications enhances model transparency, fostering trust in AI systems. We've explored setting up a Lime environment, generating explanations, interpreting outputs, and visualizing results. By recognizing common pitfalls and exploring real-world applications, you're now better prepared to use Lime to drive informed decision-making in your field. We encourage you to continue exploring Lime and its potential, ensuring that your AI models remain transparent and reliable. Thank you for joining us in this journey towards mastering Lime.